Morning, I'm Steve Bowen from PV Bicycle Center. Today I want to talk a little bit about modern aluminum frames. As I mentioned in some other videos, aluminum was a material that has been neglected for a while because of the advent of carbon fiber use in road bikes and how popular that's become. We're seeing a renaissance in the building of really high quality aluminum frames at a lower price point. So let me just talk about a little bit the history of the use of aluminum in bikes. Originally, aluminum came in to being used in road bikes at a time when steel bikes were ubiquitous. And the reason was, number one, aluminum could be made into a lighter bike and it could be made into a stiffer bike. So those were things that were really good for racers. Racers wanted the lightest, stiffest bike they could get because it made them go faster. There wasn't really a lot of attention paid to the quality of the ride, and that's kind of where you got the disparity in the early days of people saying that steel had a better ride than aluminum. If you wanted a really nice riding bike, that you bought the steel bike. Shortly after that, advent of aluminum, we started to see some other materials being used, and essentially it took away the energy from what would have been a more continuous development of the aluminum process leading up to carbon fiber bikes. So now we've had probably about 15 years worth of technology in carbon fiber bikes and a lot of energy in the market, a lot of bikes sold. Now the manufacturers are taking another look at aluminum because, number one, it's a lot cheaper. It's easier to make an aluminum bike. The material costs less, the manufacturing process is less. It's just you don't need as much sophisticated equipment to do it. At the same time, there were things that were learned from building carbon fiber frames that now they're bringing into aluminum, some of the high-tech things. Instead of making a bike where all the metal is the same all the way through, or you're joining tubes together the way you would have done in a steel bike, they're looking at every part of the bike and saying, okay, what does this need to do to make the bike do this? So the holy grail of road bikes is really three things. One is you want the bike to be laterally stiff. That means that it doesn't twist or move from side to side under load because that wastes power. Number two is you want it to be relatively lightweight because the lighter a bike is, the less energy it takes to get it up a hill particularly. And the third thing is you want a comfortable ride. So in a sense, those characteristics are difficult to get all three of without spending a lot of money. What we've done in aluminum now is use tube shaping, which is accomplished by a variety of different methods. A lot of it has to do with what's called hydroforming, where when the metal is actually hot enough to shape, they put a balloon inside of it that's filled with water and creates a certain shape, and then the metal hardens around it, and then they remove the balloon before the tubes are welded together. So if you look at this bike, it's got a very interesting shape. The top tube is fat on the top and skinny this way. So what that does is it allows us to be stiff enough so the bike doesn't twist, but it relieves weight. It also allows the bike to flex a little bit in the vertical plane. That gives you a little more compliance without wasting power and letting the bike shift from side to side. If you look at the rear triangle of the bike, which is the seat stays and the chain stays, you've got straight round tubes that are stiff. The seat stays have a little curve to them that helps the rear end compliance so the bike's not so stiff, absorbs a little bit of road shock. So the Ollie is essentially a race bike, and it's meant to maximize your power basically when you're going forward by still being comfortable. Now if we take a look at a different bike, you can see how these different characteristics are used. This is a sector. A sector is an endurance or comfort road bike. It used to be called a sport touring bike. So here you've got a bike that's meant to be ridden comfortably over a long distance. It's not necessarily the bike you ride to go as fast as possible in a criterium race or something like that. Now just for one example, take a look at the seat stays on this. First of all, they're much thinner than on the Ollie. Okay, but they're thick this way, but the sides are very thin, and then they're curved. So this still keeps the rear end from flexing, but the shape of it and the way that it's thicker and thinner absorbs a lot of road shock, both from an impact that you might hit, a pothole, something like that, that would send the shock up into your body, and also just the general uneven surfaces of a road get dissipated by the shape of this. You can also see that the chain stays are a little more bowed on this bike than the Ale. Again, that dissipates energy of shock, road chatter, things like that, makes the bike much more comfortable with the least amount of compromise in terms of losing efficiency in the bike. We can see that the top tube has a very similar characteristics to the Ale in that it's fat across the top, skinny this way, and it's got a nice bow to it. So that keeps the bike stiff where it needs to be stiff, it relieves weight, and also allows the bike to act a little bit as a spring. Now here's another thing that was learned from carbon fiber bikes. What they learned about carbon fiber was the longer you make the pieces, both the stronger, the lighter, and the more compliant it can be. So if you follow the line from the rear triangle all the way through the head tube, it's basically like one continuous curve. So that's something that was, again, learned from carbon fiber bikes. In the past, you would have seen these seat stays being attached higher up at a sharper angle, and then a completely disconnected top tube. Now, once the bike is all welded together, it functions mechanically as one piece. You can see the same thing in the Ale with a little bit less curve to it. That makes the bike very rigid back here, where you're putting most of the energy into the bike. At the bottom bracket through the junction of the top tube, seat tube, and the stays. But at the same time, it allows energy from shocks that the rear wheel hits. Instead of going up into the seat, it gets dissipated through the top tube. So again, very sophisticated use of the material manufacturing processes. A lot of things learned from carbon fiber to make a superior bike that can sell for, in some cases, thousands of dollars less than an equivalent carbon fiber bike.